Okay, then today I will introduce the digital camera and the lens optics basics knowledge of those are the systems. Okay, so outline of today's the lecture. So I will briefly explain the history of the camera, and then also very basic the system knowledge of the camera optics and the lenses will be explained afterward. Okay. So this is a very rough the history of the photography. So as I explained in the last slide, so 15th century, the first camera was invented called camera obscura. Then 1839, the first the film camera was invented. So at that time, the film is maybe I think most of you already don't know the film anymore, and then I think you are the digital generation. So maybe you only know the digital camera, I suppose, but maybe your the father mother know the film the camera, and then if you ask them, then you will see some other film camera. But those film cameras are already very compact, and then the film is something like the off the shelf, and then there's some standardized, so you can buy the film anywhere, everywhere in the world, and then you can use all the film to all the camera because it's just basically there's only one very standard the film the specs is defined. But before that, this 1839, this time, the film is totally different from those. So it's the film is like the very large, and then there is the thick, and the plate was the kind of silver was the painted on that, and then it's very sensitive. So sensitive, but need a long time to exposure. So once you prepare that and then put some of those the silver the chemicals, then you put that behind the camera and then open the lens. Then maybe usually like 1 minute or something time is required to make some the chemical or the reaction to those the plate. Then you need some the some chemical process afterward, taking time to get some the images using those films. And I think sometimes if you know this knowledge, then still or sometimes you will see some the news that the very old or 18th the century film was found in the stock or something, but it's looks like all corrupted or something. And but it's still possible to see something because it's just a plate with something like a glass, and then it's like a pile of those. Sometimes is just the put in the stock or something, and then people find that then very precious information is captured on those films, and it's still happening right now. Okay. Then the 1900, the kind of roll film was invented, and then 1935, color film was invented, and at that time, maybe the Kodak. Kodak is the world. I think it used to be the biggest the filmmaker, but it's gone right now because they failed to switch to the digital or the camera. So somehow I'm not sure, but maybe most of you don't know about the Kodak anymore. But like 20, 30 years ago, the film means a Kodak. And then and there's Japanese the Fujifilm exists, and the Fujifilm is survive very nicely. So how they survive is the Fujifilm and the Kodak both the most profit the product is a film, but the Kodak stick to the film, but Fujifilm at that time developed a digital camera. It's very brave the decision, I think, because if they sell the digital camera, then they will decrease the selling products of the film. So it's nice and bad thing. But finally, Fujifilm was the successful to survive those the hard time, and then now the Fujifilm is still exists. So, and then one epoch is maybe 1932, 35 millimeter film the specs was invented. So before that, there are several specs exist. So if you buy some cameras, then you have to buy some film specialized to those cameras. But after the 35 millimeter film was the spec was the standardized, then it's radically all the films are changed to this 35 millimeter films. So all over the world, you travel and then you can buy the 35 millimeter film, and then you can store that film to the camera, and then you can capture the camera anywhere on the earth. Okay, and another epoch is 1950. Maybe I will explain this for you later. The called the single lens reflex camera. It's still exists, but maybe will be disappear. I suppose in the coming 10 years or something. But it's now still exists. And then the 1960s, 70s automatic exposure, and the 1977 autofocus, and then but the big one is the 1995 digital camera was invented. And then, maybe like 10 years ago or something, smartphone camera is very popular. And then, and maybe now, new camera with computer photography technique is in the market right now. So like I think iPhones, the recent 2, 3 years iPhone and the Android, the Pixel camera, Pixel the smartphone, recent maybe 3, 4, 5 years, all those cameras are very small, but the quality is amazing because of the technique of the computational photography. So it's not camera anymore. So it looks like camera, but it's the cameras, the device, and the algorithm and everything is developed together. So that's the reason why like Sony is not just making the device, but they are organizing some the image processing team together with those the device team, because not just hardware but software is very important to make some new the cameras. Okay. So this is the first camera, 15th century, called camera obscura. So this is the camera. It's called camera, but it's still the tools for painting. So the one important thing is that there is the optics. Okay, so optics, and then the scenes outside is reflected on to the the board inside the box. So you just the draw or the image on uh, over. So there's the white paper, and then the images is reflected through the lens. So you just the follow or the reflected image through some the pencils or something. Then you can describe the image. Almost same as the camera. Okay, so the important thing, so the difference is that there is no film. So some people or put some the colors, very colorful colors, or some people or put the lines, very strong lines or something. So it depends on the who draw those images. Okay, the system and the reflected image is the same, but how to uh, describe, uh, draw the paint, it depends on the human factor still exists. Then for 400 years later, there is one epoch the camera invented called single lens reflex. So before that, something like this. Uh, the camera has an optics, and then behind the optics there is a film. Okay, so and the film is very sensitive to the light. So this is not the film. So people draw some the images based on the reflected the image. But the film invented, then film is so sensitive. So the usually this box was closed and they keep the inside box very dark. That means the human cannot see the inside anymore. Okay. So then what happened? So, okay, let's take the picture and then open the lens. And then maybe it depends on the film, but the very old film, you need a 1 minute or something. But the new film, okay, it's just take the 1 second or something. So open, capture, close, okay, it's done or something. But the the problem is people can not do not know it's really captured nicely or not. Okay, so once open close or black box, so then you have to bring this black box into the dark room and then open that inside the dark room and then bring out the film and then and put the film into some chemicals. Then just wait, depends on the chemicals, the some processing, and then put that, put this out, then see the result. Then, oh, it's success, or I failed to capture something. So it's kind of some take a time, and it's not a direct process. So that's a one big problem for the filming system. So this is the one solution. So that's the reason why this single lens reflex is so popular. Still, it's popular. The key point is you can see there is a two light path. Okay, so the light incoming from the lens. Then there is a mirror. So mirror change the light direction to the upward, and then you see the prism at the head of top of this camera. So you see, it's like the prism is it's not just the simple shape, but you will see the very the strange shape. So it makes the bounce 1, 2, 3, 4, 5. Okay, so on this the lens its shape is the 5 faces. So it's pentagonal, right? Like pentagon, you know. So pentagonal. So there's a one camera maker exists called Pentax. Pentax is I heard comes from this the prism. So I heard the Pentax has a patent for this prism. So then they named the company as the Pentax. But the similar the prism was also developed by some Nikon, Canon, or some other the camera makers, and then they put those the special prism here. Then before or do some chemical process, people can understand at least what will be captured through this prism. So just you see from this small the scope, then at least you can understand what's the the cameraman are going to capture. Then if you put the shutter button, then what's happened is this mirror is reflected. Okay, so this mirror physically move to the upper world. Okay, so this mirror goes up. Then here behind there's a film. So the light directly expose the film, and then the this time film is very improved. So you need just maybe less than 1 second. So this the mirror goes up physically, and then maybe less than 1 second. It's enough exposure. Then this mirror again go down and then protect this area dark. Okay, so this is the mechanism of the single reflex lens. Okay, single lens reflex camera. So if in Japan, if you go to the camera shop for the foreign people, then I think there's some the areas called SLR or DSLR, digital single lens reflex. It's still very popular because this is invented like more than 50 years ago, and then still and then the camera makers are all really uh, concentrated on developing this type of camera. And then so maybe the professional cameraman is still using this kind of camera. And one disadvantage of this camera is there is a mirror inside the camera box. So this camera cannot be make small or really small size because you need the size of the mirror, and then that mirror physically go up and then physically go down. So you need some the space inside the camera. So maybe if you know or have some knowledge of the cameras and the recent history, then the camera called mirrorless, the professional camera is now in the market because this camera is the first invented for the film lens. So this system is required. But now the digital camera don't need mirror anymore, right? Because the film is the digital the device. So if just you turn off the switch, then there is no exposure. So now you don't need any those the mirrors anymore. So the Sony's first one, the maybe I think 10 years ago or something, they first before that the Panasonic, I think the first one is the Panasonic one, was in the market, but it's not so successful because yeah, it's the I explain later, but the camera is not just the good camera or bad camera is defined mainly based on the lens. So the Sony or Panasonic produced a nice camera. No, this the mirror anymore, compact, and then it's good. But they are not the lens company. So maybe the professional people or believe that the Sony or the Panasonic lens is not as good as the Nikon or Canon or something like that. So they couldn't be successful at that time. But after that, Sony bought the Olympus, the camera maker, and then the Olympus lens is all now the Sony brand. Then the Sony is now a bit successful right now, maybe a great success. But and then the Panasonic has some the joint the work with the Leica. Leica is a very famous German the lens company. So I think the Panasonic camera is very popular because the lens is produced by the Leica. But I think the Panasonic want to produce their own lens because, as I told recently, the computational photography is not just lens, the film, digital film, or those processing, but need to develop all together to make the really the best the output. So the Sony's strategy is something like on the line. So they bought the camera maker, so they have the lens, and the Sony is have some originally have some chip, and then the processing is the Sony is a very famous company for the gaming, and they have a software. So Sony is now they have the everything in the single company. So I think Sony will make some nice cameras for coming years, I suppose. But in the future, who knows? But anyway, the Sony is now, I think, doing very well right now. At the point of the view of this the camera and the systems. Okay, so this is then now so interesting part is this is the DSLR, right? So this is the camera with the digital film. So in theory, they don't need mirror anymore, but they cannot remove mirror somehow. It's kind of the contradiction, very strange because they don't need mirror anymore, but somehow they cannot remove that because of the marketing purpose, something, some reason there. I don't know. We don't know. Anyway, okay, so that's the history of the camera, and then maybe it's good to briefly wrap up the broadcasting, the television system, history of the television broadcasting system and the video. So the mechanical scanning television, it's I actually don't know much about that. Is invented like the similar time of the camera, so 1884. Then the cathode ray tube was invented 1897, almost 20th century, right? Then broadcasting system was invented 1925. Then like after the World War II, VDR mm, uh, video or recording system was invented, and then maybe in Japan, so NHK was start broadcasting from 1953. Okay. So this is the very basic the system of the video or system. So video system is not like camera. Video system is from the beginning. It's developed as at the same time the capture system and then the some display system, because the camera is just you what you need you required is you want to store the image or what you want to take some the picture or image some other people or so at somewhere, and then the picture itself is important, and then you can bring that to anywhere. But television system is not something like that. Television system initially required to capture something, and then at the same time people want to see that from some farther away position. So, for example, or if there is the capture system in Tokyo, and then you want to see what's captured in Tokyo at here, Fukuoka or something like that. Okay. So the video system is developed need some duality from the beginning. Okay. So they don't care those capturing system. Okay, that's the one the big difference from the camera and the video. Okay, so this so maybe very old video system is just kind of transmitter. So okay, capture image, but there's no some the recording system. But those information can be transmitted to the some farther away, and then the image will be displayed there. So the left one is some mechanical system, and maybe it's interesting one, but the right or the system is the typical the camera system. So bottom one is the capturing device, and the top one is the display device. So what's done here is there's optics, and then the light information was captured by some uh, called some imaging device. But they don't need to store, just they need the intensity. Okay. So and then there is some other scanning the scene. So you need some the coil or something beam the controller. Okay. So once you get the some image you want to capture, then you don't need to capture this image just one time, because the human eye is not so or the don't have strong ability to capture very fast moving objects. So if you want to transmit the image, first see this just point here, and then next point, next point, next point, or something. You just send the information of this single point. This is bright. Okay, then send this bright information to the other part. Okay, then next point. This is bright, bright, bright. This is dark. Then send that to the another part. Then the opposite the place, you will get some information for here. Okay, I received the bright information here. Then let's put the bright the light here, like some the projector beam here, and then next information come. So bright, 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 dark, bright, bright, something like that. You can do some scanning entire scene like two-dimensional way. So it will take a time, but you can develop this using some nice electronic device. Then it can be moved very fast. So then at the display side, uh, also similarly, it will project the small dots, but it's too fast. So human can just see the single image. So for that evidence, so that so you can easily prove that just prepare the camera, and maybe you don't have those display anymore, but maybe you have some time to visit your grandmother, father's place, and then if you find those the cathode ray tube CRT, then switch on, and then it will show some the image. But if you capture the CRT display with camera, then if the shutter speed is fast enough, then you will see just a single point there. Okay, and the shutter speed is slow down, then you will see some lines, and then slow down, then it's getting the large areas, and finally you will get the single image. Okay. So the video system is something like that. Okay. So capture the scene with just the bunch of dots, and then send those information to the farther away, and then the display also project the point by point. Then the people or the eye cannot follow very quite fast the motion. So what human eye is some just see the single image, but it's not the true. Okay. And then at the same time, one nice thing, so duality is very important in terms of the optics. So the camera's optics and then the display's optics is the same. Okay, so just because you want to capture and then want to show that to some other people, so just prepare the same optics, and then the camera is through the lens. You will capture the image through the lens, and then opposite side, you will prepare some light source, and then like movies, you just the project the images transmitted from the camera, and then through the lens, you will make the nice image on the screen. So maybe yeah, today yeah, and those are the camera model and something will be explained in detail next time. So just here is may please understand that the projector and camera, all those optics is geometrically the same. Okay, so like this is a projector, right? And then I think you have a smartphone, and also some people have the SLR cameras or the compact camera. All those have lens. And the important thing is that those lens is the geometrically the same. Okay, so what you will learn through this lecture is the basic knowledge of the lens, and that means you can apply those technique not only in the camera but also to your the vision system. Your eye is also the lens. There is a ball like lens, and then also the projector and everywhere. Okay, and basically, those are the geometrically all the same. Okay. Okay. So, and then, okay. So what are the determine the quality of the, here is not just video for the camera. So the question is, okay, then there are several cameras we can buy. Like an iPhone's camera is like a 10만 yen, very expensive. Or maybe you can buy the small or the compact camera. It's like just now maybe 1만 yen or something. But some people buy the Google Pixel, and it's maybe not so expensive, but uh, sometimes you can buy the DSLR. DSLR is still, I think, 20만 yen or something, and quite large. And what's the difference between those cameras? Then, the fact is, camera is just a box, right? As same as a camera obscura. So it's just a box with lens and film. Okay, so camera is just a black box, nothing else. So then, as if you'll be a nice the photographer, then to pay a big money for the camera itself seems like the ridiculous, because as described here, the most important part is the film, and the lens is the most important part. And the film is usually in the world, the market is not so many the maker is making the film anymore. Like not a film, but digital film anymore. Like the Sony is the maybe the majority of those the constructing those the sensors. And I'm not sure, but Sony is now the iPhones, the imager is produced by Sony, I suppose, and some others. So Sony is making the most of the CCD. So then, if you buy some device, but the imager is mostly produced by Sony. So it's not, of course, it's based on the price, but it's not a big difference. All nice. Then the lens is the one very important factor. Okay. So that's the reason why people buy some expensive camera. They really check the quality of the lens because the camera itself is just box, but lens is lens has very important factor to define the quality of the captured image. Okay. And okay, so this is a diagram of the lens and the imaging device. Okay, so the camera is usually inside the box is something like this. So there's the optics, okay, lens, and then the here are described CCD, but it's not CCD anymore. Usually the CMOS, but some imager, image sensing device here, and then the light comes through the optics, and then it hit this imager, and then those the light information are converted to the electronic the information like so input is a photon, but it's converted at the imager to the electron. Then it goes through the signal processing. So effect of okay, and then so important thing is of I will maybe the next the time I will explain more detail about the geometric aspect of the lens and also the CCD or CMOS or some imager the feature is also explained, and then after that some the signal processing the process will be explained. Okay. So here, okay, then, okay, I am okay. Maybe you may understand the role of the all the lens, the imager, and the signal processing. Then, is there any ideal optical system exists or not? Or because usually people have some the ideal system, and then people develop to uh, get closer to the those ideal system. And how about the lens? Is there any ideal system or not? No, yes, of course. The ideal the lens system is exists, but as you know, we cannot make that one because of the limitation of the real system or some physical the limitation. So what's the ideal system is there is some scene here, and then the lens, if the lens can reflect all the scene as it is to the image plane, that's the ideal situation. So, or something like this. It looks very simple, but it is very difficult. I will explain why it's so difficult. But this idea itself is very simple. If something exists here, and then through the lens, through the optics, and then the scene is reflected, projected on the image plane as it is, then it's the kind of ideal system. And it looks like very simple and easy, but it's really difficult because mainly the first one is the distortion. Because lens cannot the works ideally like this. So always there is some distortion. And then also, if the scene is just flat scene, then it's okay. But as you know, the scene is 3D, right? And this lecture is dedicated to understand the 3D for from the captured image like that. So the object is not something like this, the flat the object. There are several objects behind the in the scene. So the project those the 3D object onto the single plane is basically very difficult and then kind of impossible. And then what happened? Maybe you know it's called the bokeh. The bokeh. It's Japanese, but it's now the worldwide language. It's in in English it's called blur, but blur is something like the effect. Bokeh is have some artistic feeling, but anyway, it's same blur or bokeh or something. That's inevitably occur because the lens system is it's it's if ideally we want to capture image without blur or bokeh, but it's impossible. So okay, then like 15th century, 500 years ago, what how they make the system close to the this ideal optic system. So at that time, people invented the pinhole camera. Pinhole camera is something like this. So there's a box, and then you put the very small hole. Then the light can only enter from such small hole. Then what's happened? So here, something like this. So there's outside some object. Then the light can enter the inside the box through the small hole, but it's too small, and the light cannot be bent. Its light is always straight. eh. Light, I think you learn at the high school, light is not like the sound. It's not like the sound is like a wave. So if you talk something, then you can hear my voice next row. But light is straight and it's too straight, too fast. So there's almost no of those the wave-like effect. So on the next room, if we project some laser pointer or something, but you never see anything at the next room, right? So light ray is really straight and then cannot be bent, and there is no effect of those uh, uh, like reflect some those wave kind of effect does not occur. So like this situation, if the hole is small enough, then the some object is emit some light. Or why we can see this scene? Because the scene is full of light rays. Okay, so everywhere light rays, and then the light rays, and that's maybe we can say photon, and the photon comes to my eye, and then we can see something, right? So the room and everywhere, the world is full of photon and the rays. Okay, and if you make some this box, then the full of light photons it goes straight and then enter through those small hole. Okay, then like the object outside the box will be projected to the screen inside the box, and it's always light never bent. So that means that if it's the reach to the box means the light should be the straight line. So it's always reflect. It's always project outside scene uh, as same as the ideal lens. Okay. So this pinhole camera, I'm not sure, but maybe some of you do some experiment at the junior high school or something, like just prepare some box and then put small hole and then put some paraffin or something behind the box. Then you will see some outside scene was reflected here or something. I think some people do that. I also did that at when I was elementary school student, and something like that is it's possible. But problem is this hole should be very small. If the small is large, then all the rays go through the hole. Then you cannot see the images anymore because the hole is too large. Then the scene, the world is full of lens, full of the light rays, full of photons. All those come through the big hole. Then inside it's just too much light rays, and then it's getting just bright scenes there, and then you cannot see the sharp images. So you need to make this hole as small as possible. Then what happened? Incoming ray amount of incoming ray is getting very small. That means the inside getting darker and darker. Okay, so if you make this the pinhole camera close to the ideal ideal lens, ideal camera, then inside will be getting darker and darker. And if you want to inside brighter and then make this hole larger, then the inside is full of rays, and then you cannot get the sharp the images anymore. So there's a kind of contradiction. So this pinhole camera is ideally good, and then you can make some other toy this pinhole camera box, and then you can maybe the children can enjoy, but it's far from the commercial products. It's too dark, or maybe or it's too blurry or something. So, 15th century camera obscura at that time, the lens was invented. Okay, so the role of the lens is solving the pinhole camera problem. So it's a contradiction. If you make the hole larger, then the image getting blurry. To solve this problem, the lens invented. What lens will do is the lens is kind of the large hole, and if without lens, then it introduce all the rays inside. But if you put the lens at the big hole, then the lens is something as shown this slide. Lens is concentrate the bunch of the rays to the just single point. That's a very important the ability of the lens. Okay, so the whole size getting large, but the lens is kind of filtering the rays. Any ray can enter, but if the lens exists, then one specific direction, one bunch of the rays have with same direction is reflected through the lens and then meet at just single point. Okay, so that's the one very important strong point of the lens. Okay, so using this lens, kind of the some bunch of the rays. It's basically flow rays in the world, and then there's no there's nothing uh, specific relation between those rays. Just exists randomly. But using this lens, only same directional rays are concentrated on the single point. Okay. So lens is a huge invention. Okay. And another the important factor is the lens itself is yes. And if there's ideal lens, then it's like the left side. If it's ideal lens, then the lens size getting large, but all those the rays should meet at a single point. But we cannot make the ideal lens, so there is some lens difference. So that makes the lens a little bit blurry. Okay, and then this also the light one, the light figure, direction. If the ideal lens, the direction is different, but still we want those the rays meet at the same position on the same plane. But as you can see easily that the lens, the direction is different. Then the focal point, the concentrated position, is not on the plane but on the curved surface. So that's the right problem is if you prepare the imager with some the curvature, some curved the image, then maybe this problem can be solved. But the making products with curve shape is usually very difficult. So the right one is also unsolved problem. Okay. So the lens is the very strong tool, but the lens itself is it's not the magic tool. So it basically has some limitation. Okay. And then we call those the distortion is for specialized for lens as the aberration. Okay, and the aberration theory is the researched I think more than 100 years or something. It's very important. So okay, so components of an optical system is something like this. So usually to compensate those aberration, not just single lens, but usually 3 to 10 elements of the lenses are attached together to compensate those aberration. And the famous, really famous the setting is of the lens consists of 3 lenses. This is the most typical the lens set usually used. So two lens with the simple one, and in middle of them it's the some uh, convex shape of the lens is prepared, and then 3 lens are tightly attached together. So if you buy the lens with for the camera or some specific reason, then usually those are the 3 lens attached one is maybe it's good to buy to use for all the optical purpose. And all the camera, I think, if you buy, then at least those the 3 lens attached is used for those the camera purpose. And usually to compensate those aberration and those problems, usually more than the 3 lenses, like 10 or something, is used. You just the Google, like Sony or maybe Google Pixel or Sony Xperia, the lens system, something. Then maybe some the web pages introduce how many lenses are used for those purpose. Okay, so especially zoom lens is maybe I will skip the zoom lens is too much for this lecture, but zoom lens is the kind of amazing lens, and then the zoom lens usually require not just 10 but 20 elements or something. It's required. So this is a lens system, and then another important factor for the lens is aperture. Aperture. Please remember aperture. Aperture. I think not sure most of you don't know much about aperture, but aperture is because the people don't need to control aperture manually anymore. But like the 5, 10 years ago, people have to change the aperture manually to capture the nice the quality images. But now it's all automatic, so people do not aware the aperture anymore. But all usually the camera there is some aperture inside the cameras and the optic systems, and then it's automatically adjusted. So what's aperture? Aperture is just a very simple system. Aperture is kind of the mask. Okay. And then here in this slide, this LED, the object is aperture. So the left one is the aperture size is controlled large. Okay, and the right figure, the aperture size is controlled to small. The purpose of aperture is just simple: control of the amount of the light energy. So the room is bright enough, and then usually it's too bright. Then, as I told, that light rays coming to into the camera box is too much. Then too much exposure means maybe the image getting just white, too bright or something. So to compensate that and make the aperture size, the mask size, getting smaller, then you don't. Then the light incoming light rays amount of incoming light rays will be getting smaller. Then you can control those the amount of the light using aperture. So it's just simple system. So So the purpose of the aperture is basically the controlling the light amount. Okay. So now the camera is there is some the AI behind the imaging system. So system can automatically understand it's too bright or something. Then the system automatically uh, change the aperture size, getting smaller, or it's too dark. Then the system automatically make the aperture size larger or something. So the people usually don't know need to control that one anymore. But if you have some the DSLR camera or nice the compact digital camera, not like smartphones. Then I think there's a manual mode, and then you can control change the aperture size manually. But usually you don't need to do that anymore. But if you want to capture some the difficult situation like uh, the opposite, if there is a sun behind the some target, and if you want to capture the target, but the behind the target there is a sun or something, then sun is too bright, so the system automatically make the aperture size get smaller, but that makes the target very dark. So at that time, maybe you have to manually change the aperture size larger. Then the sun is too bright, so the sun is captured as just white, but uh, the target can be captured. So the AI is very clever now, but still you need to control the aperture size sometimes. Okay. And one another the important factor is the focal length. Okay, so if you buy some lens, then the focal length is it's kind of focal length is uh, it cannot be kind of controlled. Focal length is attribute of the lens. So if you buy the lens, then the lens has some a specific focal length. You cannot change the focal length afterward. Okay, because it's a kind of physical the phenomena. So once you buy the lens, then if those the three lenses are not attached together, then of course you can control. But usually those three lenses are attached very tightly, and then you cannot move those the lens the position anymore. So that means the focal length is cannot be changed. Okay, so the choice is when you buy the lens, maybe at the camera shop, then you have to choose the focal length of the lens when you buy the lens. So, okay, I will buy the the smartphone case. It's called zoom lens. Then you can control the zoom focal length afterwards, but maybe the smartphone is usually it's the fixed length focal length, I suppose, because our zoom lens is usually the need the number of the lens like 10, 20 or something. So it's usually current technique. It's almost impossible to put those the zoom lens into the smartphone. So usually you need a DSLR or something, then it's possible. But maybe sometimes you see that some the people or bring the DSLR camera with very long the lens. That means that lens is I think usually the zoom lens, and that's a zoom lens. Okay, so zoom lens require the more 20 lenses or something. So put 20 lenses in the lens. The lens getting very large. So the DSLR camera itself is still small, but lens is much larger than the camera itself. It can be happen for the zoom lens. But the nice thing for the zoom lens is you can change the focal length. But usually in the camera, the focal length is fixed. So you need to fix the lens. So if you see your iPhone, if you have a nice the recent iPhone, then there is a three lens system or something, I suppose. The main purpose of three lens is the focal length is different for those three lenses. One the lens is short length, and then other is long or something like that. So and then the system change automatically system changes the which lens to be used to capture the image. That's the reason why there's three, four lenses installed in the one smartphone. Okay, so the one important factor is the focal length. It's very important. Okay, and then this is maybe a little bit too in detail, but of course there are three lenses here. Then three lenses have their own the focal lengths, but once they attach together, then kind of joint or the joint focal lengths. One one representative focal length is defined. Okay, so then here you see the near the light rays go through like shown here. So it's the reflected, something like this. Strange, it's not so simple. But once it's attached together, then let's consider okay, there is the physically three lenses, but forget about those three lenses, and then just imagine there is a one ideal lens here. Then what we will do is okay, input the light rays go straight, and then the from the imager, okay, the back project to the those light rays to the same direction, and then connect those two rays at those are the single plane. Okay, so this red or the light ray uh, does not exist in real world actually, but in ideal space, in theory, this the red light ray can is considered. Okay, and so it's something like this. So we can describe those light rays, and then here let's consider some this larger lens. This is a little bit difficult to see, but this green one. Let's consider there is a larger lens here exists. Then this one is the kind of joint or the focal length. Okay, there's a three lenses, and then three lenses has their own focal length. But finally, consider some ideal theoretic lens. Then this is the focal length for this joint or the lens system. Okay. So, and then this is the kind of the effective diameter. This effective diameter can be changed using the aperture. Okay, aperture can make this the effective diameter smaller. Okay, cannot make larger. Okay, so this is kind of max the aperture size. And then we call this ideal lens as the thin lens. So this called thin lens model. Okay, and then usually for the computer vision system, people just if we say nothing about that, then all the papers, all the techniques usually consider this thin lens model. Okay. In real system, single lens is impossible. So usually at least three, usually 5, 10 lenses are used, but in the paper, they say nothing about that. Usually they just say we use the camera and then the focal length is uh, 45 millimeter or something. And at that time, remember this. Real system, not necessarily just the any lens is okay, but those papers assuming there's a thin lens and then the focal length is such the joint or the focal length. Okay. So if you see the like the system configuration something like this picture, and then it looks like so many lenses and the so big system, and oh how it look why, and then the focal length is just the 10 centimeter or something, and what that or something. But please remember this. It's not related to the number of the lens and size of the lens, but always if it at least works as the camera, then the all those are the mixed, and then the one and the joint focal lengths can be calculated. Okay. And as I told you, the aperture is something like can be put anywhere, but maybe this time aperture is set here then. And this is aperture size, of course, and then you can make this aperture get smaller. Then aperture size will be changed. And one thing, please remember up maybe the usually people don't need this the kind of the values, but once you already take this lecture, so please remember this aperture is if you have some the normalized the values, then it's very convenient, right? Because the this iPhone aperture is 10 millimeter, or this pixel Android camera's aperture is 4 millimeter, or this DSLR aperture is maybe a 5 centimeter or something. It's useful, but you cannot compare. It's large or small or something. So normalized purpose, they normalize the aperture size based on the system itself. So it's called F value. Okay, so F value. So F value is the focal length divided by aperture. So using this the normalized F value, then you can easily compare the aperture size uh, uh, between the totally different camera system. So if your iPhone's the F number is like 2.8, and then some other people's the Android Pixel's F number is like 8 or something, then you can easily understand, oh wow, or this Pixel or the Android is 8 and the iPhone is 2.8. Then it's then it's smaller. Smaller F value means brighter. So all these iPhones, the aperture is very large, and usually large aperture means the good lens, because aperture is large means that you can get the more light information. Okay, so this the F value is usually the smaller the better. Okay, so and if you buy the camera, then you can easily find the specification. So if you have your camera, then Google just Google and then find F number, F value or something. Then usually it's the lens, there are some specs on that. And if it's like 2.8 or 4, then it's usually a nice camera. And then maybe the cheap smartphone or something, then these F values will be a little bit larger. And I think I don't know much about the F value for the smartphone, but I think 1.4 or 2 is maybe impossible, I think. But DSLR is like big camera then. Usually this F value is 1.4 or 1.8 is the common. So that means that one reason why the people are still using the large the DSLR, because the aperture is really large. Because, yeah, it's natural, right? Because of smartphone, your lens, it sounds like this size, but DSLR is a lens, is this size. Okay. And then it's easily compared with this F value. Okay. So please remember, and then this is one maybe a takeaway slide. So please remember this one. So what is the brightness of the image? So what defines the brightness of the image of the camera? Okay, so as I explained, F value, so aperture. This is one very important the parameter for the brightness. And then of course the shutter speed, of course, right? So if you the shutter speed is fast, means that just small motion, then the incoming light or the energy is very short. But if you open the shutter speed very large, open and then close, this is large, then of course you can get so many lights. So shutter speed is, of course, it's very easy and it's linear, right? If you open the shutter like 1 second, then and if you get to the one energy, then if you open the shutter speed 2 seconds, then you will get the two energy, right? So the exposure time is, of course, very important. And then the last one is sensitivity. It's ability of the sensor. If you maybe it's very common right now, but the Sony's uh, Sony's special or the imager is it's uh back. 二面照射型sensor. Back projected imager is, I think Sony's patent or something, I suppose, but that's so amazing. And the sensitivity is so high. And I think now you can use smartphone at if you have some drinking party at night, and then go outside the drinking place, and then you can capture the all the people without flash, I suppose. But it's like 10 years ago, it's impossible. It's too dark. It looks like bright, but the midnight, just a light is not bright enough. So the people must require the flashlight, but still very dark. But it's really the improvement for the sensitivity. And now I think the people don't use the flash anymore at the night. It's amazing the improvement for this film sensitivity. Okay, so if you are interested in the improvement of this the film sensitivity, then you just Google and then find the maybe 5 years cameras or 10 years cameras some report of the camera. Then you will see ISO. ISO is the kind of standardized the value of those this sensitivity. So ISO or larger the better. Larger the sensitivity is higher. So like yes, the one simple fact is the eye is like maybe 20, 30 years ago or before or the digital the film the physical film ISO 100 is standard. So if you go or the some film shop and then you would buy the film, then usually I think 70% is ISO 100, Fujifilm, Kodak film or something like that. And then the Kodak is produced on a very famous, the nice film, expensive one, and it was ISO 50. Sensitivity is low, so you need the exposure time twice to capture the same the bright image compared to the ISO 100. But the resolution is higher. So if people want to capture the nice image, then people or bought ISO 50 Kodak Chrome. It's very famous one. And similarly, Fuji film sold the Fuji Belvia. Fuji Belvia is also ISO 50. So usually people buy just ISO 100, but if you want to capture an image at some wedding ceremony or something, then people at that time bought an ISO 50 Fuji Belvia something to get the nicer the image quality. But now ISO is amazingly, I think the digital film ISO it's exceed 10,000 or something, I suppose. That means 100 times the high sensitivity compared to the 30 years ago. That means like 30 years ago, capture the izakaya scene without flash is impossible. It's if you forget to bring your flash and then capture like go out, just capture some outdoor at the izakaya or someplace at night, then it's all black. You can capture nothing at that time because ISO 100 means you can capture almost nothing in the night. But now its ISO is 10,000 or something. Then you don't need flash anymore. So these three factors are the most important factor to capture the image. So I'm not sure, but the most of you, I don't know, have some chance for research or something. But if you have some chance to capture the image through the research, just okay, let's capture some the images outside and then bring that to some the further research or something. Then keep in mind those three values are the most important because if you go somewhere and then capture and then bring back the image and then the image quality is so low, then maybe you'll be very disappointed. So always the keep in mind the capture images for all the research purpose. Then those three factors should be always considered. Okay. Okay. So now you have you will use a smartphone. Also, it's not easy to uh, control those values, but it used to be like this is one SLR camera. Then at that time, it's those the three values are easily uh, um, kind of changed, modified with those the mechanical system. Okay, so you will see the bottom one is shutter speed, and then and the middle one is the focal length. So this is the you have to adjust all the time to avoid blur, and then the top one, this is aperture. Okay, so you can see the 1.4. This is so this lens is good because the max aperture is 1.4. It's very bright lens. Okay, and then on the 16 is the max F value, means it's the smallest aperture size is 16. But I think now 22 or maybe those are the small aperture size exist because the sensitivity is getting increased. Okay. Uh, Maybe this is a very old camera. So at this time, go outside, most brightest one is the sun. And under the sun, ISO maybe 100 and the 16, very small aperture size is kind of maximum. If you uh, make the aperture size 22 smaller, then even outside under the bright sun, you can capture almost nothing. So that's the reason why the lens is usually maximum aperture is 16, used to be, but now it's much smaller aperture size exists. Mainly because ISO is not like 100 anymore. It's like 1,000 or 5,000 or something like that. The focus. Okay. Oh, okay. And the focal length is as I explained. Here just the single lens is described, but always remember it's a kind of an ideal lens. So just single lens is impossible. Okay, so if you need to buy some the single lens for some purpose, then please remember just single lens is the quality is really bad. Okay, so if you need to do some experiment, not using the digital camera, but like some the microscope or some your own optics, then always remember not just single lens, but must prepare several lenses jointly to make the image quality as the normal the quality. Okay, but here it's ideal lens, so it's I just described single lens. Okay, for the simplicity. And then this the focal length is also the joint focal length. Okay. And the focal length is what's the focal length? So if there are two lenses, one is a long focal length and the other is a short focal length, then the captured image is the area size will be different. Okay, like this is a long focal length and this is the short focal length. Then the lens position is, of course, a short focal length. You can get closer to the imager, right? But the imager size is all usually the same. Okay, so that means the lens system getting closer to the imager. Then just simply you can see that the area can be captured by the lens is getting larger. Okay, so this is just simple. Okay, all please remember. Like if you have a lens, two lenses, one is 100 millimeter and the other is a 50 millimeter, and then you have to choose one of them. And then maybe some the professor told you, please capture the image as wide as possible. Then which one you choose? Of course, 50 millimeter. Okay, 100 millimeter is narrower the view uh, area. Okay, so if you want to capture wider the area, then choose the shorter focal length. Okay. Please remember, and this is also the take home or the slide. Okay, and then so this is just the high school math. It's just the high school math. Anybody can understand. Alpha is just the tangent the 2f by s. And then multiply by 2. High school math. Okay. And then maybe this is just the knowledge. So as I told you, like the 1934, the there's 35 the millimeter film was invented, and then it's conquer all over the world, and everywhere if you go to the camera shop, then you can buy the 35 millimeter lens. So this is so important. And now there's no film anymore, but still, like most people think the size of the film standard is this 35. That's strange. But so maybe because the DSLR is it's have like 50 years like history, and all those systems dedicated to the 35 millimeter the film. That means not only the system but lens, everything is optimized for this 35 millimeter the film. So that's the reason why still all those lens and all specs are first consider this 35 millimeter film. Now, 35 millimeter film is not exists, and people don't need to stick to this one. But still, it's interesting. But like imager size can be the larger. It's possible right now, but still, the image. So Sony, like those imager company, makes some this 35 millimeter size imager because there's the certain the need requirement there because so many people have DSLR with lens. So, okay, the imager size is 35 millimeters. Then people can use all the lens with some certain the specs, certain ability. Okay, so still there is some 35 millimeter the imager is produced. And also, 35 millimeter the film is like, I think 90, 95 or 98, 99% most of the market at the time. But one another the specs exist. Maybe I think your mother, father, grandmother don't know much about this one, but the researcher or the professional photographer, of course, know this size called 6 by 6 inch, 6 inch the film. The film is larger. That means the image quality is, of course, getting higher. But it's but this is not so common. So the camera system is expensive, and the film is also expensive, and so it's just used for the special purpose, like wedding ceremony or the commencement, like the entrance ceremony day or something. Then a professional cameraman prepare this big film to capture the nice image. Okay. And the digital camera era, it's getting the smaller to smaller because it's silicon and it's to make the large the imager is really expensive. So the usually such small lens, small the CCD and the imager was produced for the digital cameras. Okay. But of course, it's too small. So that's the reason why now the kind of professional or the digital cameras, the image size is getting larger and larger. I think the 1 inch is now very popular, I suppose. 2/3 inch is, yeah, 2/3 is still okay. But now I think the popular one is 1 inch or something. So this is the same I already explained. And then also considering in the past, so as I told you, the 35 millimeter film was the world standard. So, and here, so based on this one, the focal length and the wide angle of view of alpha is defined based on sensor size. So the sensor size, if we have the two, so it's okay. So we want to capture like okay, we want to capture like 60 degrees the field of view. For example, this room is maybe more than 60 degrees. Like, okay, I want to capture all the students. So, okay, next time I will bring like 120 degrees cameras. Then I can capture all of you. And then, okay, I will bring some the cameras. Then, and to capture all these 120 degrees, what's the length of the lens I need? Then, to calculate that, I need to know this sensor size, of course, right? But okay, I have a camera, but this which camera should I use? Maybe this one is good, but this sensor size is the 1 inch, and this one is good, but this size is 0.5 inch, and so it depends. Okay, if I use this one, then I have to prepare this lens. This one it's very complicated, and then it's too much, and it's kind of confusion. So sometimes people will still use the 35 millimeter film lens, the normalized the focal length. It's very strange because the 35 film is not exist anymore. But if you go to the camera shop and then there is a lens on the shelf, I think, and then this lens is like uh, 50 millimeter. This lens is the 100 millimeter. This lens is a 28 millimeter. Those are the focal length is all based on this the 35 millimeter film. Okay. And then another importance and the takeaway information is standard lens. Okay, so if you buy the camera and then the shop or the people ask you, so, okay, if you have kind of nice money and then your the relative or your uh, brother or sister ask you, please take a nice picture of my wedding or something, and then okay, and then you go to the camera shop and then you will buy it, not the smartphone but kind of DSLR for or the nice important day for your friends or something. Then maybe the shop people will ask you, okay, and you will say, I want to buy this DSLR. Then maybe the shop people ask you, then okay, what kind of the lens do you want or something? Then maybe you will say, kind of standard lens or something. Then the standard lens means this 50 the millimeter lens in terms of on the 35 millimeter the film basis. Okay, and this for this standard lens means same as human eye. Okay, so please remember, if you go to the camera the shop or something, and then if the shop people told you like, okay, do you want a standard lens for this system or something? That means it's just simple, same as human eye. So if you see this scene and you want to capture as you see, then 50 millimeter standard lens is good. Okay. But if you want to capture the wider, a little bit wider than your eye, then maybe 28 millimeter or something lens is good. And then if you want to a little bit the closer, and then something like if you go to the concert and then you want to capture the nice idol or something, then maybe you have to buy 100 millimeter or something. Then you can capture all target sun specific the person. Okay. So please remember this one. Standard lens, 50 millimeter, same as human eye. Okay. So this is an example of the angle view. So here, the left the bottom one is a 50 millimeter. This is human eye. Maybe you will understand, it's like maybe we go there, then it's like looks like what we see. But like the right one is a zoom. So it's like 800, 200, 400 something. It's something like the a telescope, right? So telescope. So similar to telescope. So it's 200 is it's human eye cannot see such detail, right? So so 200 is good for telescope. Okay. And also one another important thing is perspective. Perspective. So focal length is not just define those the field of view, but one another the aspect is perspective. So if there's two lenses, different focal lengths, and if object like this one, then it will capture like this, right? And then capture the same object with same size, but you have to get closer, right? Because the focal length is shorter. Then you will see the different perspective effect like this. Okay, so this is another the aspect of the focal length. Okay, so of course you can capture the same person, same object, the same size, but perspective effect is different. So this the image show images shows you the effect of the perspective. Okay, so here the human the model size is all the same, right? But the focal length is different. So to capture like this, the cameraman moving forward or backward. Then what's happened is you can see the background image is totally different. It's the same situation, totally same the environment, but the capture just short length, 70 millimeter. Then you have to really get close to the object. But the 70 millimeter is a very wide angle, right? So you will capture so many the background or the scenery with this the situation. And a 50 millimeter is just human eye. So it's very looks natural. But like 135 or 300 millimeter, it's maybe the cameraman really moving farther away from the target. Then that means the background is almost just zoom, and then you can get very limited information. Okay. So that's the reason why if you want to capture some uh, idol, or they prepare the zoom lens because uh, the short length, then the background is too much. So it's something like the very crap information, right? You cannot concentrate on just the target, but so many information captured the back as background. But if you prepare the zoom lens, then the background information is compressed, so not so much information, and then the target object is just that looks very impressive. Okay. Yeah, and this is a similar effect. This is similar one.